Good morning, Pp3. Here with you, Ms. Randa Wahid. Today we have a new session in Unit 5, Lesson 2. It's about the relation between the inscribed and central angles subtended by the same arc. Let's start. Here, angle BMC, its vertex here in the center, so it's the central angle. It's what? Central angle. What is the meaning of inscribed angle? Inscribed angle, that means its vertex on the curve of the circle, But look here, angle BMC and angle BAC, both of the two angles here subtended by the same arc, which is CB. Now we're going to know what is the relation between the central angle here and the inscribed angle here. Okay, let's see the definition of inscribed angle. It is an angle, the vertex of it lie on the circle, and its sides contain two chords of the circle. Of course, look here, AB and AC are two chords. What about the central angle? It has what? Two radii. It has two radii. Inscribed angle has what? Two chords. Okay. So let's take the first theorem for this lesson. The measure of the inscribed angle is half the measure of the central angle, subtended by the same arc. Look here, if I have here AMB, its central angle, so ACB, which subtended by the same arc AB, its inscribed angle, so it's equal half the central angle. Okay, half the central angle. Okay, and I have three cases here. First case, okay, if M belong to one of the two sides, M, which is the center, belong to one of the two sides in the inscribed angle, or if M is a point inside the inscribed angle. Okay, or if M is a point outside the inscribed angle, outside here. Look here, look here, where is this central angle? Here, AMB. Where is the inscribed? ACB. Here, where is the central angle? AMB. Where is the inscribed angle? ACB. Look here, A and B. I'm going to mention it. This is the central angle, and this small one is inscribed angle. This is the central angle, and this small one is inscribed angle. Here, central angle, and this small one is inscribed angle. Look here, the same arc here, same point here, and same point here. Okay, so same arc. Okay. Look in this exercise and let's try to solve it. Here I have the angle X, which is ACB, it's inscribed angle, so it's equal the central angle. What is the central angle here? AMB. What's half 110? Half 110, or 110 over 2. It's what? 55. Nice. Let's see here. Here I have y plus 10 is what? Is double the inscribed angle. So y plus 10 equal 80. Y plus 10 which is the central angle, is double the inscribed, so it's equal 80. Okay, so y equal what? Go with the other side with minus, so y equals 70. Okay, let's see this one. Here I have the inscribed angle 70, so the central one is the double, so 3z plus 20 equal what? 3z plus 20 equals 70. Okay, I'm going to take this to the other side with minus, so 3z equal 50. We didn't take care of this. It's not 70 times 2. Okay, 70 times 2 because it's central angle. Okay, finish this first, so it will be what? 3z equal 140 minus 20, so it will be what? 3z equal 140 minus 20, it will be 120. So z equal 120 divide 3. 120 divide 3 is 40. Okay, nice. Let's see this. This is 115 and this is its central angle. So it's what? It's double 115. What's double 115? 230. And you can solve it as equation like this one or like this one. Okay, you're going to say 3L plus 10 equal 230 and solve it. Here, this is 45 inscribed angle. What about the central angle? It will be what? Central angle will be double of 49, which is 90. Okay, if this is 90 and this equal that because they both 3D, so x equal what? It's a base angle in isosceles triangle, so it's equal 180 minus 90 divide 2. 180 minus 90 divide 2, which is 45. Okay, let's see this one. What about this? You can just draw the radii here. Look, just draw the radius. Sorry, just draw the radius here. All of them are equal. This equal that equal that. So if this in the triangle AMC 32 here, so 32 here. And in the triangle CYB, this 25, so this will be what? 25. Okay, so both of them are how much? All of this, it's what? 57. 57. This is an inscribed angle. So what about the what about the central angle? It's double 57. What doubles 57? What double 57? 114. 114. Very good. So you can solve number 7 and number 9 by yourself. It's the same as we took here. And this one you also will draw the radius. So this equal that and equal that. Okay, here 55, so this will be what? 55. If this parallel to that, so this 55, here also 55. 55, this is a vertex angle in isosceles triangle. CMB, isosceles triangle. So how can I get the base angle? Base angle of isosceles triangle, how to get it? 180 minus 55 over 2. Okay, then you can get the L. It's okay. Let's continue our lesson. Here. Look here, he's telling you that this is perpendicular, and you want to prove that. The measure of AMC, look here, AMC. You're going to tell me, Miss, AMC, neither central angle nor inscribed. It's not central or inscribed. So what we're going to do, we're going to just draw the radius here, MB. So I have all now the central angle, which is AMB. Okay? Central angle and its inscribed angle, which is suspended by the same arc AB, ADB. Okay? So let's see here. If this is perpendicular, remember? What we said, this is a radius and this is a radius. Okay? And if this is perpendicular from the radius perpendicular to a chord, that means this part equal that one. Okay, very nice. So this angle will be equal that one. Okay, this angle equal that one. Very good. So let's see here. Measure of angle AMC. Measure of angle AMC equal measure of angle what? What is the other part here? BMC. BMC, which is half what? Half what? The whole angle, which is AMB. Very good. So the inscribed angle here, and the central angle, what is the central angle with this inscribed? It's the same, AMB. AMB. Very good. At what is the arc? What is the suspended arc? It's AB. AB. Very good. So the measure of the angle that he so the measure of the angle what? AMC. AMC, this part. AMC equal what? Equal half AMB. That's nice. So the measure of angle AMC equal AMC equal what? AMC equal what? A D B, as you want to prove. Okay? Okay, nice. Easy one, easy exercise. Look here, I have two corollaries here. The measure of an inscribed angle in a half. The measure of is a half. The measure of subtended arc. Subtended arc. Okay? Okay. So if he give you AB as an arc, okay, you can get the inscribed is half the arc. And the central angle is equal the measure of the arc. Okay? Very good. Let's see the other corollary. The inscribed angle drawn in a semicircle. Semicircle, what about the semicircle? We said what? Semicircle means 180. Its central angle is 180. Its central angle is 180. So the inscribed angle is what? Is 90. Is 90. Is right angle. Is right angle or 90. Very good. Okay. Let's solve some exercises here. We have here, this is what inscribed angle, and its arc is 92. So x plus 1, tell me, 2 times x plus 1 equal 92. Okay, the double of 92. Okay, okay, so we're going to say what? That 2x plus 2, we're going to double this because it's inscribed. Okay, so how to do it? Let's solve. We're going to say that 2x plus 2 equal 92. Okay, and you're going to solve it as equation. Go here, there was minus, so it will be 90. 2x equal 90, so the x equal what? 45. Okay, and he's asking me to give him the arc AB. The arc AB, which remains from the whole circle. What is the whole circle we said? The whole circle is 360. So 360 minus what I have here. I have here 110 and 92. 110 plus 92. Okay, and then you can solve it. Here, I want measure of angle A. Measure of angle A is what? Look here, its subtended arc is 140. Subtended arc is 140. So, it's equal what? Angle A. It's half the arc. Half the arc. What's half 140? It's 70. Very good. A or AC. AC. So I have here, this is 70. Okay, and I want the arc which is AC. How can I get it? I have here its inscribed angle. Inscribed angle equal what? 60 plus 70. So this angle will be 50. Okay, this angle will be 50. Very good. If this angle will be 50, so the arc is 100. The arc is 100. Very good. Let's see here. Now we have a well-known problem. So important problems. Let's see. Let's understand it very carefully. Here, if I need this angle, look here. This is a chord and this is also a chord. This is not diameter, it's a chord. So intersection between two chords, it makes of course vertically opposite angles here and vertically opposite angles here. Okay, so angle AEC equal angle DEB. Okay, and now I want to get AEC, the measure of angle AEC. How to get it? And first we're going to draw AD. Okay, and since the angle AEC, look, the needed angle here that I wanted, it's what? It's outside, it's exterior angle. It's what? Exterior angle. What do you remember about exterior angle of triangle? It's equal what? The other two angles, but not it's adjacent. Okay, the other two angles, the sum of the other two angles, but not its adjacent. Okay, the other two angles, which is interior angles, except it's adjacent. So the measure of angle AEC equal measure of angle EAD plus ADE. Very good. But look here, this angle ADE is what? It's what? Inscribed angle. Inscribed angle. So it's equal what? This angle half the measure of arc AC. Is it right? Yes, it's right. And what about this angle? DAE, DAB, all of this, look here, and this angle, all of this. DAB, it's inscribed angle. What its arc? It's DB. So the inscribed angle equal half DB. So I can take off the D and write half measure of arc AC, and take off the A, measure of angle A, and write half measure of BD as an arc. So you can take the half as common factor. So it's half what? Measure of arc AC plus BD. Okay? So take care of this, so important. We're going to use it so much in the coming problems. Okay? Let's see the other well-known problem. Here, if the two rays carrying two chords in a circle, look here, the needed angle here is outside the circle. Look here, returning back, the needed angle here was where? It was inside the circle. So if it's inside the circle, we're going to use half the arc which is in opposite to it, and the other arc plus the other arc. But what about if it's outside? Look what you're going to do. This will be half what? The bigger arc minus the smaller one. The bigger arc here minus the smaller one. Look at this. It cuts it cuts these two parts of the circle. Cuts these two parts. So if two rays carry two chords, here this is a chord and this is a chord and this is a ray, are intersecting outside it, intersecting in E, then the measure of their intersecting angle equals half of the measure of the major arc which is AC, subtracted from it half the measure of the minor arc. This is the minor arc, okay, in which both are included by the two sides of this angle. Okay, very nice. How to make it? We're going to draw CB to make what? Inscribed angle. The inscribed angle CB8 equal what? Half the arc AC. Very good. And the inscribed angle DCB. Can you see it? DCB. Half the arc is what? BD. Okay. So, and the angle ABC. ABC. I'm going to check it to make it for you. This ABC. It's what? It's what? Exterior angle of this triangle. Okay. So it's equal E and this angle. Okay. The sum of them. And we said this one is what? Half this arc. And this angle is half this arc. Okay? So, by algebraic solution, we're going to have the measure of angle E equal measure of angle ABC minus measure of angle BCD. Of course, I'm going to take off ABC and put its arc. And I'm taking off BCD and putting its arc. So half the measure of the arc AC minus half the measure of the arc BD. Take the half as a common. Then half measure of AC minus measure of BC. Okay? So important here. Okay. Let's solve some exercises here. I want to get this X. How to get it? The two chords intersecting inside. So I'm going to use which one? I'm going to use the rule with plus. With plus. So the X equal what? The X equals half its opposite arc, which is 114, plus the other arc, 60. Okay, very good. Okay, and here, what we're going to do here, we're going to get this one first, okay, which is half 100 plus 50, and angle Y will be 180 minus what we get. 180 minus what we're going to get. Okay? You can solve this too by yourself. Let's see this one, This angle is outside the circle. How we can solve it? By the rule of the minus. Half the major arc minus the minor arc. So half what? 100 minus 30. Okay? And you can solve it. Very good. Here, how can we get this one? He's giving me this. So I'm going to double this. If I double this, it will give me the difference between the two arcs. From the rule, we're going to just adjust the rule to get this angle. Okay? So if I double 28, it will give me what? It will give me 56. Let's write it. So 56 equals what? EC minus 30. Solve it as equation. Go to the other side. So the EC or Y equals what? 56 plus 30. 56 plus 6. 86. Okay? It's what? 86. Okay. Let's complete. Here I have here measure of angle A is 36 and this arc 104, and I need to get BD. How to get it? Of course we said that measure of angle A equal half what? The major arc minus the, which is what we're going to write? EC, measure of arc EC minus measure of arc BD. Of course you write measure of arc. Okay, here, so 36 equal half what? EC, which is 104, minus BD, which I don't know. And I'm going to solve it. Here, this will be what? Times 2. Times 2, it will give me what? It will give me 72. So this will be 104 minus 72. It's equal 32. Very good. And here DE, it's equal BC. So it's equal 300 minus 140 plus what? Plus 32, which we get equal 188. Okay, both the two angles, the two arcs. But the two arcs are equal, and I want one arc, so I'm going to make divide. 188 divide 2. So it's equal what? 94. Okay? It's easy one. Okay. Thank you very much. See you next session.